Hi, this is Jeline from the Honors Tutorial. Our topic for today is about vertical and horizontal asymptote of rational functions. This is for Mathematics 11 under General Mathematics. So let us have the direction here. Solve for the vertical asymptotes of the rational functions. Example number 1 is f of x equals x minus 1 over x plus 2. Now let us have the definition of asymptotes. It is a straight line that constantly approaches a given curve but does not meet any infinite distance. So let's solve for the vertical asymptotes. If you want to solve for the vertical asymptotes, you have to focus on the denominator only. So therefore, for our solution, we will be getting the denominator only. So that is x plus 2. And our goal is to have x only at the left side of the equation in order for us to get the vertical asymptotes. And then we have to equate this to 0. And then after that, we have to transpose positive 2 at the right side of the equation. Then it will become x equals negative 2. Any number, any variable, any term that you are going to transpose at the left or the right of the equation, you have to change its symbol or sign. So if it is positive, then it will become negative. If it is negative, then it will become positive. So that's it for the vertical asymptote. Vertical asymptote is x equals negative 2. Next, for example 2, we have here f of x equals the quantity of x plus 4 times the quantity of x minus 4 over x plus 3. Same process. Let's focus first on the denominator since this is for the vertical asymptote. Let's equate x plus 3 to 0, then have x only at the left side of the equation. We will be transposing positive 3 at the right side of the equation, then it will become negative 3. And that's it. This is the vertical asymptote already. Next, example 3. So we have here f of x equals 3x squared minus x minus 10 over 4x squared minus 6x plus 2. Focus on the denominator only because we are just getting the vertical asymptote. Let's write solution here and then copy the given for the denominator. And that is 4x squared minus 6x plus 2. And then since this is a trinomial, kindly prepare two parentheses here and then think of factors of 4. We can use 2 here. This is trial and error. Therefore, later we are going to check if our wise guess is correct. And then x squared, as you can see here, our exponent is telling us how many x's do we have, and that is 2. So I can give one x here and the other x here. And then, for us to get the second term for each parenthesis, I want you to focus on the third term and then think of factors of positive 2. But you have to consider that we have here negative symbol at the middle of our equation. So therefore, we should have two negative numbers for us to get a positive number when we multiply and also when we add. That is also a negative number. So I will choose negative 2 and negative 1. So I will be writing negative 2 here and negative 1. Now, I want to be sure that my answer is correct. So let's use FOIL method. This is just to check if our factors are correct. So that's 2x times 2x, that is 4x squared. 2x times negative 1, that's negative 2x. Negative 2 times 2x, that's negative 4x. Negative 2 times negative 1, that's positive 2. Now let's combine like terms. So we have here 4x squared and then combine this because they are like terms. Because they have the same variable and same exponent. Since they have same sign here, which is both negative, we will just copy it and then add the numbers, which is 2 and 4, that's 6. Then copy the variable, which is x, and then plus 2. As you can see, our denominator here and our answer here match. So therefore, our factors are correct. So let me just clear the checking part here, and then we will be proceeding. So we have to solve for this separately in order for us to get the vertical asymptote. For 2x minus 2, we have to equate it to 0 and then transpose negative 2 to the right side of the equation. Then it will become 2x equals 2. And then our goal is still the same, to have x only at the left side of the equation. So we have to divide both sides by 2. So we have here x equals 2 divided by 2, that's 1. Next, equate 2x minus 1 to 0. Then we have here 2x equals negative 1. Transpose it to the right, then it is positive 1. Same goal, have x only at the left side of the equation. So therefore, we have to divide this both sides by 2, which is the numerical coefficient of x. So we have here x equals 1 half. So these are the vertical asymptotes. So we have here x equals 1 and x equals 1 half. Let's continue. Let's solve for the horizontal asymptote. These are the conditions that we should follow in looking for the horizontal asymptote. First one is if n is less than m, then y equals 0. N is the exponent of the numerator and m is the exponent of the denominator, the leading coefficient. Letter B, if n is equal to m, then y is equal to a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So for letter C, if n is greater than m, then there is no horizontal asymptote. I will give you example. For this, n is the exponent of this leading term and m is the exponent of the leading term of the denominator. So exponents are n is equal to 1, m is equal to 2. We can say that n is less than m because n is 1, m is 2. So therefore, y is equal to 0. And this is our horizontal asymptote already. We just need to follow these steps. Next, identify n. This is n. So that's 2. Identify m. This is m. That's 2. So we can say that n is equal to m because n is 2, m is 2. So therefore, if it is equal, we will use y equals a over b. A is the coefficient of x squared in the numerator, and that's 10. B is the coefficient of x squared in the denominator, that's 1. So 10 over 1 is 10. So the horizontal asymptote is 10. And lastly, n is 3, m is 1. Though it is invisible, but it is there, it's 1. We can say that n is greater than m. Therefore, no horizontal asymptote. Okay. That's it for vertical and horizontal asymptote. I hope that you have learned something today about those topics. If you have questions, clarifications, or inquiries about us, kindly message the Honors Tutorials page. Thank you and God bless.